All right, so today's unit is space exploration, and we're going to look at topic 1, which is called For Our Eyes Only. So we'll start by talking about something called frames of reference. So we know the sun moves through the sky in the daytime, and then the moon, the stars, and the planets, they're moving through the sky at night. And we've noticed that these objects in the sky, they rise in the east and they set in the west. And people have been seeing this motion in the sky for thousands of years. So we know that this motion is caused by Earth's rotation. We know that the objects do not revolve around Earth. It seems that way. It seems as if everything in the sky travels around our planet. So a frame of reference is it's just a set of axes of any kind that is used to describe the positions or motions of things. So when we make observations, we use Earth as a fixed frame of reference from which to view the sky. So what were our ancestors seeing? So first of all, celestial bodies. These are all objects that are seen in the sky. So they include the sun, the moon, the stars, the planets. They're all referred to as celestial bodies. And so many ancient civilizations, such as Greeks, Babylonians, Hindus, Egyptians, they built up a knowledge of about the stars. There was the belief that the stars were revolving around Earth. They saw that the stars were making unchanging patterns in the sky. These patterns, they looked like objects, and so people grouped them and named them, and those groupings are called constellations. Some examples: Orion the Hunter, Ursa Major, the Great Bear. So on each successive day, a given star, it rises and sets 4 minutes earlier than the day before. So that means that over a period of months, different stars are in the night sky. And since each month has its own set of stars in the night sky, people started to develop the ability to predict the changing of the seasons, and that helped lead to the creation of calendars. So the sun, it rises and sets at a different rate from the stars. The moon, it also rises and sets at a different rate from the stars. We also learned in grade 6 the moon phases, the different phases of the moon, like the crescent, the gibbous, and so on. There's 5 other bodies: Mercury, Venus, Mars, Jupiter, and Saturn. They also rise and set at rates different from the stars. So the ancient Greeks, they considered these to be special stars, which they called planets, and that came from the Greek word wanderer. So ancient legends, there's lots of different myths and legends. So many ancient societies, they created stories to explain the origin and movements of the celestial bodies. For example, to the ancient Romans, Jupiter was the king of the gods. To the ancient Egyptians, the sun god Ra was carried daily through the sky in a sacred boat. The Algonquin, Iroquois, and Narragansett saw the constellation Ursa Major as a bear running from hunters. So lots of different myths and legends. So I'm just going to pause. So next we're just talking about sky coordinates. So people wanted to accurately measure the locations of celestial bodies in the sky, so they had to come up with more accurate ways. So each celestial body was given 2 coordinates measured in degrees. There's the azimuth. It's the first angle measured clockwise from north. There's the altitude. It's the second angle. It's measured the celestial body's angle above the horizon in degrees. And then we have the altitude azimuth coordinates. These are the angles that are used to specify the coordinates of a celestial body. So they are the coordinates that locate a celestial body relative to a fixed Earth. So it's as if the celestial bodies are circling Earth. And these coordinates for each celestial body, they do change depending on the time of the reading. So technological devices, astrolabe, or astrolabe. This was a device created, used to measure the altitude of an object. It was invented by ancient Greeks. It's held vertically from a ring with a pointer on it. And then the pointer was used to sight a star and then measure the angle to it. So this is from the 9th century. This is a more modern one made in 2013. A compass is used to measure an object's azimuth. It was imported from the Arabic world about 1200 CE. So with these tools, navigation began to improve and the great sea explorations of the world began. Quick video here. All right, so stars could be used as a frame of reference to track the actual motion of each celestial body. You need to use the stars as a frame of reference instead of Earth. That's because you're looking for motions in the sky that are different from the big motion caused by Earth's rotation. So for example, if you want to see the actual movements of Mars, so one night you'd find Mars in the sky, find a few bright stars near Mars, mark down the position of Mars relative to those bright stars. Next night, find Mars again and the few bright stars again, and then mark down Mars' position relative to those few bright stars. And if you made similar observations over several weeks, you can see in which direction Mars is really moving. So using the stars as a frame of reference. Next, we get into the different models. So here, this was the Earth-centered model, also called geocentric. Geo meaning the Earth. So this is with Earth in the center of the universe. So even with their advanced knowledge of how to track the motion of the celestial bodies, ancient peoples, they still believed that the stars circled around Earth. It was based on the ideas of the Greek philosopher Aristotle. So it was reasoned, that since the stars in the celestial sphere were visible from Earth, it was reasoned that the inner spheres had to be crystalline or transparent. That was one part of Aristotle's model. Then came Ptolemy. In Ptolemy's model, the planets were attached to smaller spheres called epicycles, which were attached to the main spheres. So shown here, these were called the epicycles. And then came the sun-centered model. So in the early 1500s, Nicholas Copernicus, he was a Polish astronomer. He proposed a different model to explain the view from Earth. He proposed that the sun was fixed and a rotating Earth revolved around it, rather than Earth being fixed and the sun traveling eastward through the stars. So this was called the sun-centered or heliocentric model of the universe. Now keep in mind, it was hard to accept this model because it was also going against the church. So it took a long time for this to be accepted. So Copernicus, his model, it uses perfect circular motions and the planets have epicycles. It was about as good as Ptolemy's model in predicting celestial motions. But the crucial difference is in this Copernicus's model is that the planets orbit the sun, not Earth. Just going to pause here. We'll watch these videos.